Tweaking Component Colours to be Distinguishable in the Sunlight by Vernon Fowler. 10 Years of Alibytes 2022.
Hello everyone, my name is Vernon Fowler. I'm a Senior UX Designer at Nutrien Ag Solutions. Today I'll share with you how we achieve enough visual contrast to be able to see information on a screen in direct sunlight. It's a fairly common situation for farmers and agronomists. Success for seeing in direct sunlight requires a contrast ratio of 7.5 to 1. This slide shows two of our message components after we improve the contrast. First is a message with red text and the background colour is a pink that's light enough to achieve the 7.5 contrast ratio. Second is a message with a light orange background colour. This time the brown for text was chosen to achieve the contrast ratio and for its similar hue to the background colour. For the rest of my presentation, I'll describe the process and a couple of free tools I use to achieve enough contrast. The agenda. First up, how much is enough contrast? Then I'll show how to assess colour pairs. Then how to increase contrast with a new colour. And I'll finish with what success means for who and when. To measure contrast, I'll use the Web Content Accessibility Guidelines, WCAG, to definition, the relative luminance of text against a background colour. Contrast ratios can range from 1 to 1, which is no difference in luminance, up to 21 to 1, which would be pure black on white. To gauge how much is enough contrast so that we can see information on a screen in direct sunlight, I use a web-based tool, whocanuse.com. Whocanuse brings attention to how colour contrast can affect people with visual impairments and in situational vision events. The WCAG AA contrast minimum is a ratio of 4.5 to 1. According to the 2022 WebAIM Million report, 83.9% of home pages have text with less contrast than this minimum. Moving up, the Whocanuse tool estimates a minimum contrast ratio of about 5.7 to 1 for people with cataracts or low vision. Up again, the WCAG AAA contrast enhanced ratio is 7 to 1. This ratio generally provides compensation for the loss in contrast sensitivity experienced by users with low vision who do not use assistive technology. It also provides contrast enhancement for colour deficiency as well. But to pass the Whocanuse direct sunlight test, we need a ratio of 7.5 to 1. I used the Whocanuse tool to assess the colour pairs we started with. Our initial palette was designed to comply with the WCAG AA contrast minimum. Let's take a look at how our original colours tested. Assessing the red text against the original pink background gives a contrast ratio of 6.72 to 1. This is more than enough to pass the WCAG AA contrast minimum. Putting the colour hex codes into Whocanuse, red on the original pink background fails the test of direct sunlight on a phone or screen. Assessing the original brown text, shown here in the links and heading, against a light orange background gives a contrast ratio of 4.53 to 1. This also passes the WCAG AA contrast minimum. Once again, putting the colour hex codes into Whocanuse, the original brown on light orange fails the direct sunlight test. It also fails another situational vision event, night shift mode, as well as tests for cataracts and low vision. After learning where our colour contrast fell short, I set out to increase contrast ratios by shifting to a new background or text colour. To find new colours that have enough contrast, I use another web-based tool, Tanaguru Contrast Finder. Like the Who Can Use tool, we input the hex colour codes. You can select an option for the minimum contrast, 3, 4.5 or 7. But for other contrast values, we must adjust the ratio URL parameter in your browser. So to find colours with enough contrast in direct sunlight, I set the ratio URL parameter to 7.5. With a 7.5 contrast ratio against red, Tanaguru found one similar pink colour. So we adopted this as our new light pink. This time with a 7.5 contrast ratio against light orange, Tanaguru found 16 similar brown colours. From these, we chose the brown with the hue nearest to the background colour, and we adopted this as our new brown. Shifting to new background or text colours increased our contrast ratios to 7.5 to 1. Our new colour pairs passed the direct sunlight test. At Nutrien, success for farmers and agronomists is when they can see information on a screen in direct sunlight. This level of contrast not only can be seen in direct sunlight, but also passes tests for night shift mode, cataracts, and low vision. Changing colours for successful contrast is a simple process with free web-based tools. At Nutrien, teammates and I are remediating our entire functional colour palette to achieve this. So what does successful contrast look like for your users? Are they all going to be indoors? Will they be driving around? Will they be working on building sites? It's great to think about contrast with the WCAG guidelines, but we need to go beyond that and think of how our sites will be used by people in the real world. Thank you for listening to my presentation today. Please reach out if you have questions or comments. You can find me at vfowler on Twitter and LinkedIn.
Celebrating 10 years, AliBytes 2022.